This is a pump control valve, which controls when the pump turns on and off. In this video, the valve is disassembled, inspected, and reassembled. This might be done in response to the valve not working properly or as a standard maintenance procedure. Before starting, remember to isolate the valve by turning off the upstream and downstream isolation valves and the auxiliary feed line connected to the pilot system. Control valves are sometimes located in confined spaces. Before entering a confined space, remember to always check for hazardous air conditions, have a backup person standing by to help you if needed, and follow all other safety procedures associated with confined spaces and the operation and maintenance of control valves. Confirm you have all the tools you might need on hand. To disassemble the control valve, you'll need a few adjustable wrenches and a set of end wrenches, a permanent marker, a flat blade screwdriver, a hammer, and a cold chisel. If the bearing has to be removed, you will also need a vise and either a large screwdriver, or you can make a tool like this, which is a 6-inch long bolt welded to a piece of plate steel, about 1.5 inches long and 1 inch wide. Also, a homemade stem rod like this, which is a 1/4 inch bolt welded to a rod, can be used to help remove and replace the diaphragm assembly. Turn off the power to the micro switch at the electrical control panel and remove the switch from the valve. Twist out the rod that connects the stem to the micro switch and lift it up. Then remove the plug from the valve cover. If water has been leaking along the rod, the O-ring inside the plug is likely cracked or broken and will need to be replaced. Remove the copper tubing. Using a permanent marker, mark where the solenoid attaches to the cover. In addition, mark the cover, the middle body, and the main body of the valve. Remove the solenoid and the nuts that fasten the cover to the body. Release the cover by placing a cold chisel under the lip and tapping up with a hammer. Then lift the cover off and inspect the bearing in the top. If the bearing has burrs or is worn on the inside, causing the stem to bind, clamp the cover in a vise and remove the bearing using either a large screwdriver or a tool like this, being careful to not damage the inside part where the stem slides when installing the new bearing. Using the homemade stem rod, lift out the diaphragm assembly, which is connected to the middle part of the valve body. Inspect the seat for signs of damage, wear, or cavitation, and replace if necessary. Remove the stem nut and the diaphragm disc. Notice that the smooth side is toward the diaphragm. Remove the diaphragm and the lower diaphragm disc, which also has a smooth side that needs to be against the diaphragm when reassembling. Remove the stem. When removing the nut that holds the disc guide tight against the retainer, do not grip the stem on this larger part. Doing so might score the surface, resulting in leaks or damage to the O-ring inside the sleeve. Keep the stem from turning by gripping it in this area on the smaller part of the stem below the threads. It might be necessary to put the stem in a vise to break the nut loose, but be careful to not allow the stem to twist in the vise. Remove the lock washer, the disc guide, and the fiber spacer washers. Each valve is calibrated in the factory with a specific number of washers so the disc guide fits properly against the disc. So keep track of all of them and if they need to be replaced, use the same number as were removed. If the disc is cracked or damaged, it can be removed with a screwdriver. If the disc is leaking and a spare is not readily available, it can be flipped over and used until a new one can be obtained. If the stem has gouges, scrapes, or burrs and needs to be replaced, the disc retainer can also be removed. The stem slides inside this bushing. If the bushing is damaged and needs to be replaced, remove the lock ring with a screwdriver and push out the bushing. A dental pick can be used to remove the O-ring inside the bushing if it is worn out. Replace the bushing and lock ring using one of the diaphragm discs or other similar object to keep the bushing from sliding out. Replace the disc retainer on the stem, then the fiber washers and the disc guide. The lock washer and the stem nut. Replace the stem through the bushing. Install the bottom disc plate, diaphragm, top disc plate, and the stem nut. Screw the stem rod into the stem and use it to replace the diaphragm assembly on the body of the valve, using the marks made before removal to line up the assembly in the correct position. Replace the cover, again using the marks to line it up properly. Replace the nuts on the cover, using the marks made previously to install the solenoid nuts in the correct position. Tighten the nuts in a crisscross pattern to ensure even pressure on the diaphragm. Replace the plug, being careful to not damage the bleed screw located on the nut. Push the rod down and screw it into the stem. Replace the micro switch. Replace the solenoid. Replace all of the copper tubing, leaving the top fitting of all tubing loose to allow air to bleed out when pressurizing the valve. Reconnect the auxiliary water and turn on the ball valve to fill the control valve with water. Manually close the solenoid valve by pushing down the brass nut and twisting it to lock. Loosen the bleed screw on the plug. Once air stops bubbling out from the copper tubing fitting and the bleed screw, tighten the screw and fitting until water stops running. Turn the brass nut on the solenoid valve and let it return to normal operating position. The water discharging from the copper tubing is from the cover, allowing the valve to open. As the valve opens, the stem rises. When it reaches the fully open position, the micro switch is activated. To make the valve open slower, screw in the adjustment screw next to the copper tubing that provides water to the cover. The valve now opens much slower by reducing the flow amount from the cover. To make the valve close slower, screw in the adjustment screw on the auxiliary side of the solenoid. These screws are adjusted on site as needed to keep the valve from opening or closing too quickly and causing water hammer. This completes the training video for maintenance of a pump control valve, produced by the Rural Water